In this video, I'm going to go over two quadratic word problems, example number 1 and 2. They're mostly with finding vertex and using the vertex to tell the minimum or maximum function value. So these are the wordings that I got from your Alex homework. It says a ball is thrown vertically upward. So let's say that I throw a ball. Pen's not working. Throw a ball, it's going to go upright, it's going to hit the highest point, and it's going to come back down, right? So let's say that's a trajectory. Or if we're looking at the height is going up and height is coming down. But at one point, it's going to reach its highest point. Do you agree? Okay, so what are we doing here? After t seconds is height h and feet is given by the function h of t equals 68t minus 16t squared. Do you see what they did here? They switched a and b. They switched the order. We usually write the quadratic term first. The one with the exponent of 2, we have to write that first. I'm going to do that. Minus 16t squared. And then you notice the 68t, this is a positive term, right? This is positive. There's no negative in front of it. So you can do plus 68t there. Now I did that so that I can tell what a is and what b is. A is negative 16, b is 68. I guess you don't really need to rewrite it, but I like to keep things in order. Okay, what are we doing? Let me read what they want. After how long will it reach its maximum height? Now, what variable are they looking for? They're looking for after how long. They're asking for time, isn't it? So they're looking for how many seconds later, okay? Is it going to be 5 seconds, 10 seconds? Not sure. But you know when the maximum, where the maximum will happen in a quadratic. It's going to happen at vertex. So keyword alert. Whenever a problem is asking you to find a maximum or minimum, find vertex. Why? Because you've seen your quadratic functions, all these that we graphed, maximum happened at the vertex, right? Minimum also happened at the vertex. Vertex is where this highest point or lowest point will occur. So whenever they ask you to find maximum or minimum on a word problem, a quadratic word problem, you have to find the vertex, okay? Now the vertex formula is x equals negative b over 2a. But it looks like instead of the variable x, they're using variable t, right? Instead of saying h of x, they have h of t. So I'll just say that the vertex formula is t equals negative b over 2a. Time is equal to negative b over 2a. What's that going to be? Let's see. B was positive 68, so I had to put negative 68 on top of the fraction, and I did 2 times negative 16 in the bottom of the fraction. Guys, very often, you know how fractions are usually better in a math class, right? Because they're accurate. But we're talking about time here. So I think this time decimal will actually be better. So let me go ahead and type up the fraction here. Negative 68 divided by 2 times negative 16. And they gave me a decimal, which I like, 2.125, and what's the unit? Seconds, because T stands for seconds. So you throw a ball, it's going to go up for 2.125 seconds, and it's going to reach the highest point, and after that, it's going to come back down. So when they ask you that question, after how long will it reach its maximum height? Our answer is 2.125 seconds. So just like that, we solved our very first word problem, right? Again, the hint is whenever a quadratic word problem is asking you for a maximum or minimum value, find the vertex. And the reason that I stopped here is because I found what I needed. I found how long, like what second, after how many seconds will it reach the maximum or the vertex. But the next one, we have to do just one more step. So I'll read example 2 and go over this one with you now. A supply company manufactures soda machines. The unit cost C, the cost in dollars to make each soda machine, depends on the number of machines made. If X machines are made, then the unit cost is given by the function. All right, there comes the function, and it's a quadratic function. And what's happening here is that whoopsie, sorry, it should look like that. I know this is a function that's opening upward because the leading coefficient is positive 1.5, so this graph will open upward, right? So what's happening is the more soda machines you make, the cost was going down, unit cost was going down, but you know, after a certain point, I guess it's gonna go back up. So what should they do? If the cost is going up, maybe they should stop making it. So this is a point where they will have the minimum cost, the lowest point, lowest cost in dollars to make each soda machine. All right. Let me read what they want. What is the minimum unit cost? Here is the keyword. Whenever they ask you to find a minimum or maximum in a quadratic word problem, find the vertex. The vertex formula is x equals negative b over 2a. A is 1.5, b is negative 486. Let me plug them in. Negative 486 is positive 486. I do 2 times 1.5. All right, I'm about to plug this in to get a decimal or a whole number. And we'll talk about what that number means. 486 divided by 2 times 1.5. That comes out to be 162. 162 what though? $162? We have to look at this problem very carefully. What does X stand for? X stand for machines. So we're looking at 162 soda machines. So this is what we know. If this manufacturer makes 160 soda machines, they can minimize the unit cost. Okay, but what were they asking though? Look at the wording of what they were asking. They were asking what is the minimum unit cost. So we're not done. Okay, we know if they make 162 soda machine, the cost in dollars will be minimized. But what is that actual unit cost? In order to find that, we're going to plug this 162 into the unit, the cost function. So this time, because they were asking for the output value, the cost, I have to plug in 162 into the function. 1.5 times 162 squared minus 486 times 162 plus $85,241. All right, so how much will this supply company, what will be the unit cost for this company if they make 162 soda machines? I don't know, let's find out. So 1.5 times 162 squared minus 486 times 162 plus 85,241. Look, the minimized cost is, let me write this down, $45,875. That will be the minimum cost, okay? See, I did this algebraically, just finding the vertex using the vertex formula. But what will this look like graphically? So I just, out of curiosity, I'm going to go ahead and graph this. Desmos graphing calculator. So if I graph C of x equals 1.5 times x squared minus 486 times x plus 85,241. I don't even see the graph. Where is the graph? The graph is, wow, it's very, very narrow. So you know what? Let me try something. Let me try to change the setting of this graph. I will stretch the horizontal axis to maybe like 100 and -1. Maybe I stretched out too much. It's just hard to find the perfect window to show you guys what I wanted to share with you. Okay, hold on. This teacher's trying. Okay. Oh, that's good. All right, hold on, you guys. You see it? I try to change the graph a little bit so that it looks like a parabola, okay? Now, where is the minimum happening? Somewhere down here, right? I mean, they plotted a point for us right there. So this means what they did was they actually plotted a vertex, okay? And they said the vertex is happening at x of 162. That was the number of soda machines, right? And the minimum value is 45,875. Let me see if I got those numbers right. I got 162 soda machine. That was good. And also 45,875, okay? It was just hard for me to find the perfect setting of the zoom setting, the window. But when I just, stretched it or made it enough so that it looks like a parabola, I was able to just click on a point and they were able to give me the vertex. So I don't know if the graphing will be very helpful when you do these word problems, because the real numbers, like these dollar amount, they're big. So you may not be able to see a perfect graph in a standard window of a graphing calculator. But you don't really need to do this graphically. You know how to find the vertex. You know how to plug that x value into the function to find the y value. So I suggest you do that whenever a word problem is asking you for the minimum or maximum, okay?